Okay, so we learned about different forms of a quadratic, right? So we learned about vertex form, which looks like something like this, right? Remember, that's vertex form.
Yes.
And then we learned about standard form.
Yes.
Something like that. These are all quadratics. They all form a parabola of some sort. We're going to learn about the third one. Remember, we did our foldable. This is intercept form. And it looks something like this, which is just what we did, right? We just factored. We know how to factor now. So we're just going to learn about how to like graph things from intercept form and things like that. So let's start by reminding ourselves how to graph in different forms. Okay, so if we have this one, 2x minus 1 squared minus 4, let's figure out how to graph that. Do you guys remember? What form is it?
Vertex.
Okay.
And then you just find the vertex.
Yeah, so this just tells us our vertex, right? So this tells us that our vertex is at 1, -4. So we use that to graph our vertex. So we go over 1, down 4, 1, 2, 3, 4. And is it facing up or is it facing down? Up, because it's a positive A. And then when I go over 1, how far do I go up? 2. That 2 tells me I go over 1 and up 2. Over 2, up 4, or up 8, but do kind of a quick one there. It's supposed to go through that point. How do you guys feel about graphing from vertex form, 1 to 4? 1 means I still have no idea what you're talking about, 4 means I got it. Okay, so we're close. Close. Still need maybe a little practice, but we're pretty close. All right, standard form. This is the one we just did. We just talked about this a few days ago. Do you guys remember how to find the axis of symmetry from standard form? Exactly. Axis of symmetry is our -b over 2a. Okay. So we do -5, which is -5. So we do the opposite of b, which is 5, over 2 times a, which is 4. So that's a little challenging. Those were bad numbers, but that's okay. It can have an axis of symmetry at 5/4, right? That's a number, right? So it's like 1 1/4. So we draw our axis of symmetry right here. Our axis of symmetry is right there. It's at about 1 1/4. And we have to figure out where our vertex is for this one. So you get to plug back in a fraction. That's cool. So we plug this in for x, remember that? So we go 2 times 5/4 squared minus 5 times 5/4 minus 3.
So do you square what's in parentheses?
Yes, you square that first. So we have 2 times 24 over 16, 25 over 16. Just thinking ahead of myself. 25 over 16 minus 25 over 4 minus 3. There's a lot of,
Why is it 25?
because the 5 times 5/4, 5 times 5 is 25.
Oh, wow.
No, you're good. You're good. You'd be surprised how many times people say that's 25 over 20. It's not. We just multiply the top, right? Okay. So then we multiply and we end up with 25 over 8, right? Because these cancel, minus 25 over 4 minus 3. Well, 25 over 4 is the same as 50 over 8. So we have 25 over 8 minus 50 over 8 minus 3, which we can make into 24 over 8. Yeah, so we multiply both top and bottom by 8.
Negative 25.
Yeah, so 25 minus 24 is negative 1, or is positive 1 minus 50 would be negative 49/8.
Yeah.
Oh, that's terrible. This was poor planning. Sorry, guys. Negative 49/8. Let's figure out.
It looks scary because it's 25 and 3.
So it's a little over 6. Little over 6. So our vertex is at 5/4. And then a little over 6. 1, 2, 3, 4, 5, 6. So 6 and an 8. So it's somewhere here. Guess what's not scary in standard form? The y-intercept. Because remember, the y-intercept is where x equals 0. So we just do, we put that equal to 0. And so our y-intercept is negative 3.
Wouldn't the, for the vertex, the y-coordinate be negative?
You are correct. Thank you. As I was looking at that, I'm like, wait a minute. It's going to be further down because can't have an x-intercept of negative, or y-intercept of negative 3. So we go down 6. Sorry. 1, 2, 3, 4, 5, 6 right here. A little over 6. And then we intercepted 3. And we kind of reflect that across here. It's like about there. Make a note to change those numbers to numbers that are actually nice. Sorry. But you get the gist? Find the axis of symmetry, find the intercept, find the vertex, and we graph it. How do you feel about this one? How do you feel about, not this one specifically, but in general, the ones we've been doing where we graph from standard form? Give me a 1 to 4 on how you feel about it. Okay. All right, we might need a little more practice because maybe
It was just the big numbers. That's what got me.
maybe if this one wasn't so scary, it wouldn't. Okay.
Ugh.
Sorry about that. We'll do some more practice on this on Monday. But I want to talk about intercept form today. I want to talk about intercept form because this is the third form.
Let's just not go. Let's not leave school.
This is the third form that we use, right? And it looks like our factored. Sometimes people call it factored form. Sometimes people call it intercept form. You're going to hear it both ways in this class. So, why in the world does it matter if I put something in intercept form? Like, why do I want to use it, right? We know why we use vertex form. Vertex form shows us the vertex. So it's a nice form to use, right? Standard form is just standard because it's like, I don't know, it's the way we've always done it, right? But why do we even need intercept form? Why do we need a third one? Well, we put it in intercept form because it shows us where the zeros of the graph are. What are zeros? Zeros are the points at which the graph crosses the x-axis. Show you how that looks. So if we look at that, so here is a quadratic. The zeros are where it crosses the x-axis. See that? So the zeros for this quadratic are 3 and negative 4. We also call the zeros solutions. We also call them x-intercepts. This is really important that we call them solutions. Because when I say, hey, let's find the solution to this quadratic, what I'm asking, tell me where it crosses the x-axis. Tell me what the x value is where it crosses the x-axis, which is also what x value is a zero. Okay, I'm looking for the zeros. Okay, so when we're solving quadratics, we're looking for zeros. Stop yourself, this is really bad. Okay, they are the answer to the question, when is the function equal to 0, right? When is f of x equal to 0? So if we look at the factored form of this and we set it equal to 0, so let's factor this first. Okay? Let's factor this quadratic. This is one that we could graph from standard form. We could find the vertex and all of that. Let's factor it. We need to get to a times c is 6 and b is -7. So we need to multiply to that and add to that. -6 and -1 does that for us. So we write x minus 6 and x minus 1. And then since we did a slide, we've got to do a divide. So this is x minus 2, and this is 3x minus 1. So this, in standard form, these two are the same parabola. If we graphed them, they would be the exact same parabola. They're just in different forms.
So that one's standard and that one's vertex.
Yes. Oh, no, this one is intercept.
Oh.
Standard and intercept. Because vertex is that one, remember it has the square by it, and we can see the vertex in it. Standard and intercept, because this tells us the intercept, that's why we call it intercept form, because it tells us where it intercepts the y-axis, or the x-axis. Okay, so if we set this equal to 0, this would say, we would say x minus 2 times 3x minus 1 equals 0. How do we solve that? Let's find out.
Oh, don't you like
You don't have to FOIL.
Don't you like set equals to 0?
Yeah. Yeah. So here's my question. If this one was equal to 0, what would the whole thing be equal to?
Sorry, what?
If this factor was equal to 0, what would the whole thing would be equal to 0? Because if I take something, doesn't matter what this is, this could be 100 million inside of this, right? If I multiply it by 0, the whole thing becomes 0. If this one is equal to 0, and I multiply it by who cares what's inside of here, I get a 0 as well. Does that make sense? So one of the factors, if either factor is equal to 0, the whole thing is equal to 0. So that's what we call the zero product property. The zero product property. It says if a product of one of the real number factors is 0, then at least one of the factors has to be 0. So that's the mathy way of saying if either one of those happens to be equal to 0, then the whole thing is equal to 0. It wipes the whole thing out. Okay? So if we had A times B, if A was 0, the whole thing would be wiped out. If B was 0, the whole thing would be wiped out. So if we go back to our example, this one, what are the zeros of this one? Well, we set x minus 2 equal to 0. We set 3x plus 1 equal to 0, and we solve them. So we want to get x by itself, so x equals, we add 2 to both sides, x equals 2. So when x equals 2, this factor equals 0. Does that make sense? Because if I put 2 in here, 2 minus 2 is 0. So when x equals 2, this whole thing is wiped out and becomes 0. Okay? Now this one would be 3x equals -1. And x equals -1/3, that's the other 0. So this one says, if x equals -1/3, yes?
Positive. Because isn't it -1?
Yeah, so you subtract 1 from both sides, and then you divide by a positive 3.
No, but up top you said it's -1, so it should be -1 in the bottom, which means it should be.
You are correct. I wrote this down wrong. Thank you. That looks like, okay, 3x minus 1, so that's a positive 1, so that's a positive 1/3. Therefore, if x equals 1/3, and I put it into here, it wipes this out, it makes this become 0, and the whole thing equals 0. So the zeros of this parabola are at 2 and at 1/3. That means it crosses the x-axis at 2 and 1/3. So let's see, let's try a few more. X squared plus x equals 42. Let's figure out what the zeros of that one are. So we have to factor it. But it doesn't look like things we've been factoring before, does it? So we gotta have 0 on one side and everything else on the other. So we're just gonna subtract 42. So we're gonna have x squared plus x minus 42 equals 0. Then we can factor it. We gotta add to 1 and multiply to negative 42.
It would be -6.
Thank you. Negative 6 and positive 7. So we have x minus 6 and x plus 7. So this and this are the same thing, right? So I set that equal to 0. What are my zeros of this function? Positive 6 and negative 7. Why?
Because you add the 6 and you subtract 7.
Yeah, if you put them equal to 0, you have to add 6 to one side and get 6, and if you have to subtract 7. So I could set each of these, I could be like x minus 6 equals 0, and x plus 7 equals 0, and solve. So the zeros of this are at negative 7 and 6. Just going to cross the x-axis at those points.
So you're switching. Like, if one is
Uh-huh.
positive, that would be
Mhm.
negative, and that would negative, that would be positive.
Yes. Great. This is why x always lies. This is like the whole math behind why x lies, is the whole factoring thing and setting them equal to 0. I know. It's tricky. It's tricky because you look at it and you're like, oh, it must be negative 6. No. Okay, let's try this one. 2x squared minus 9x plus 5. So we'll get it equal to 0, so we're going to subtract 2x from both sides. 0 equals negative 2x squared minus 9x plus 5. We're going to factor that. It's going to be negative 10 and negative 9.
Negative 10 and positive 1.
Perfect. So we're going to write our factors as x minus 10 and x plus 1. And I did my slide, so now I got to do my divide. Divide by negative 2, divide by negative 2. X plus 5 and negative 2x plus 1. Because I multiplied by a negative 2 to begin with, I need to divide by a negative 2. Feel good about that?
So then how did you get to 0?
So these equal 0, and remember the zero product says either this equals 0 or this equals 0. So I set them both equal to 0. X plus 5 equals 0, or negative 2x plus 1 equals 0. So I have x equals negative 5 is one option that would wipe my my whole equation out, right? Or I have negative 2x equals negative 1, divide both sides by negative 2, and I have x equals 1/2. Yes or no? Yes? Kind of? Somewhere in the middle, like a 2? Like a 2? So if it was already written in intercept form, you could just look at it and you could say either this one has to equal 0 or this one has to equal 0, and you could find the two zeros of your function just like let's try one more. This one's tricky. X squared equals 9. So we go x squared minus 9 equals 0. Then we factor, and do you remember what this is called? Not a perfect square, those are slightly different, but you're right. Difference of squares, right?
Yeah.
So we know that this actually looks like x minus 3 and x plus 3 because it's the difference of squares.
So we just,
Yeah. Our zeros are at plus or minus 3. Here's a quick question for you. Could we have solved that without factoring? Can we get x by itself without factoring?
probably.
Let's look. I wouldn't be asking if you couldn't, would I? Okay. How do I undo squaring something? I take the square root of it. So x gets all by itself, and the square root of 9 is?
Positive or negative?
Plus or minus 3, because we could square negative 3 and get 9, or we could square positive 3 and get 9. So I could actually solve, if I have something like this, I could solve by using the square root as well, and it tells me the zeros. So I got x all by itself, and it told me the zeros, either way. Does that make sense? Sorta? Okay, so, oh gosh, that went all sorts of crazy. When we are solving a quadratic equation, we're really just looking for the zeros. So, I want you to try solving these on your own. And that will be the last thing for today. Try solving, we're just looking for the zeros.